I wanted to do a quick example in which you had to use the sandwich theorem again. So in this problem, we want to evaluate the limit as x goes to 0 of x squared sine 1 over x. So to use the sandwich theorem, we have to show that two conditions are satisfied. One, that there's an ordering of our functions. There's a smaller function g of x, which is less than or equal to f of x, which is always a function we're trying to find the limit for, which is less than or equal to a larger function h of x. And this is with the possible exception of, in our case, at x equals 0, because we never care about what's happening at the limit point. The second condition that has to be satisfied is that the limit of the smaller function, to whatever limit point that may be, has to be equal to the limit of the larger function. So we're going to test each of these things. And one thing I'm going to note is that I have here x squared being multiplied by sine of 1 over x. And recall, we know that because of the unit circle, draw a circle here, that the sine and the cosine, whenever I make an angle, are always going to be the x-coordinate is cosine of theta, the y-coordinate is sine of theta, and so with the unit circle, the largest that sine or cosine will be is 1, and the smallest it will be is minus 1. So I can use that information to now order my function x squared sine 1 over x. So x squared sine of 1 over x is the f of x. If I'm going to order it, has to be in the middle. I know that this sine of 1 over x will always be bigger than minus 1, so this is always going to be bigger than minus 1 times x squared. And I know that sine of 1 over x will never be bigger than 1, so it's going to be sandwiched inside of x squared, and of course times 1. So the sandwiching here is minus x squared is less than or equal to x squared sine of 1 over x is less than or equal to x squared. So this is condition 1 of the theorem taken care of. Now this is now the function g of x. Of course, the middle function is always f of x, and the larger function, we call that h of x. Now for the second condition, I need to check the limits of the smaller and larger functions. So the limit as x goes to 0 of minus x squared, simply plugging in 0 for x gives me 0. And take the limit as x goes to 0 of x squared, again plugging in 0 gives me 0. So now I see that the limit as x goes to 0 of g of x in our particular problem is equal to the limit as x goes to 0 of h of x, and they both equal to 0. So the first two conditions of the theorem are satisfied. And now I know the conclusion must be true. So, therefore, by the sandwich theorem, well, what do we know? We know that the limit as x goes to 0 of x squared sine of 1 over x must be equal to 0. And this is how you need to do your problem that's due tonight in the assignments.